Module 6.12, Free Field Environment and the Inverse Square Rule. Have you ever noticed that as a sound source moves away from you, that it gets softer? This should be something that you've experienced throughout your life. Let's look at why this happens. Imagine that you are blowing up a balloon. The balloon is made of rubber and it has a certain thickness. As you begin to blow it up, the balloon expands, and as the balloon gets bigger, it should be obvious that the skin of the balloon must get thinner since there is a fixed amount of rubber. If the balloon was a perfect sphere, we could estimate how the thickness changes. The surface area of a sphere is 4 pi r squared. So as the balloon expands, the surface area is getting bigger and the radius is getting bigger. So if the radius goes from 2 inches to 4 inches, the radius is doubling. But because the surface area is times r squared, the surface area quadruples, times 2 squared or times 4. So since there is the same amount of rubber, that means that the balloon skin must be 4 times thinner each time the radius doubles. Now, imagine instead of a balloon that we're talking about sound pressure. When sound radiates from a source, there's a fixed amount of force that is produced. Since pressure is force over area, if the surface area goes up by 4 times, then the pressure must be 4 times less because the force remains the same. With sound, this will occur in an environment where there are no surfaces to reflect the sound. We call this a free field environment. In a free field environment, the change in sound pressure level can be represented by this formula. The change in SPL equals 20 times the log of d1 over d2, where d1 is the starting distance and d2 is the ending distance. So now let's imagine that you are 1 meter from me in a free field environment and that I am speaking to you at an SPL of 70 dB. Now, if you go from 1 meter to 2 meters, what will be the change in dB? So the change in dB is 20 log of d1 over d2. 20 log of a half equals minus 20 log of 2. The log of 2 is 0.3, so minus 20 times 0.3 equals minus 6 dB. So going from 1 meter to 2 meters, this would now be 64 dB. Let's see what happens now if we go from 2 meters to 4 meters. So the change in SPL is 20 log d1 over d2. So we have 20 log of 2 meters over 4 meters. 2 over 4 equals 20 log of half, which equals minus 20 log of 2 equals minus 6 as before. So we would then go to 58 dB at 4 meters. What we've done is we've doubled the distance from 1 to 2, and it's 6 dB. We've gone from 2 to 4, and it's minus 6 dB. So this is an example of what we call the inverse square rule. The inverse square rule states that in a free field environment, sound pressure level will decrease by 6 dB for every doubling of distance. You can consider being outdoors, away from any reflective surfaces, as being a free field environment. However, when you're inside, there are walls, floors, ceilings for sound waves to reflect back off of. And as a result, the sound pressure level will not decrease as much when you are indoors. To review, a free field environment exists when there are no reflective surfaces for a wave to reflect off of. In a free field environment, SPL will follow the inverse square rule, decreasing by 6 dB for every doubling of distance. The change in dB in a free field environment is 20 log d1 over d2, where d1 is the starting distance and d2 is the ending distance.